In this video, we will look at how to provide a context-free grammar for the language L, the set of strings W from alphabet 0, 1, such that the length of W is odd and its middle symbol is a 0. So first, let's create our list of strings in the language and a list of strings that are not in the language. So, the shortest string we can have is a single 0. Its length is 1 and its middle symbol is 0. Next shortest, we have to jump to strings of length 3. And they only have to have a 0 in the middle. That's the only requirement. So it could look like this, or like this. We could also have strings of length 5, have a 0 here. Okay. So we could make this is an infinite list, so we could go on. Strings that are not in the language. This is a string with odd length, but its middle symbol is a 1. Any string of even length will not be in the language. Or we could also have strings of odd length that do not have a 0 as the middle symbol. So anything like this. Okay, and this also is an infinite list. So, as a first attempt, you might think about creating the 0 and then building the left and right sides. So a grammar might look something like this. And what can left go to? Well, we could build a 0 or a 1 or epsilon. And similarly, we could do this. Okay. Now I claim that this is a problem and that we can't build the left and right sides independently. Why is that? Well, once we start building the left side independent from the right side, we cannot keep the middle symbol for sure as a 0. So an example derivation using a grammar like this, so this is going to give us L0R. Okay, now I have a choice to build my left side basically however I want to. So I could take the rule L goes to L0. And now I can take the rule L goes to epsilon. So now I have 0, 0, R. Okay, so right now you might say, well, it looks okay, but just bear with me. Okay, now R can go to, let's use the rule 1R. So I have 0, 0, 1R. That would look more like a 1. Now R could use the rule 0R. And then R can use the rule R goes to epsilon. Okay, so you can see here, not only do I not have a string of odd length, but I don't have the one. I don't have a 0 in the middle. Okay, so we now notice that our left and right sides are not independent. They are actually quite dependent. Okay, so let's try another tactic. Instead, let's think about how we would build the following strings. And for these strings, they're going to be very dependent on each other. So let me just give you some strings. I have a 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0. Okay, so let's call this string W0. Let's call this W1, W2, and W3. So something that we notice is that the later strings are composed of the earlier strings. Okay, so W1 is actually equal to 1 concatenated, let me make these ones, 1 concatenated to either side of W0. Likewise, W2 is a 0 concatenated to either side of W1. And W3 is a little different, but it's a 1 on the left of W2 and a 0 on the right. Okay, so if I start with W0, then it's here, oops, it's here when I build W1. Then W1 is here when I build W2, and then W2 is here when I build W3. Okay, so this gives us an idea that we could build something from the inside out, if you will. Okay, in other words, if I take any string that's already in the language, so for example, W0 was a string in the language, I can attach, so let's say W itself is in the language. What can I do to W and end up with another string in the language? Well, W prime can be equal to anything from this set. I could add zeros on either side. I could add ones on either side. I could add a 0 and a 1, or I could add a 1 and a 0. Okay, so this is going to give us our idea on how we're going to, how we could build up these strings. In fact, our grammar is going to work the other way. It's going to work backwards. It's going to build from the outside in. Okay, so let's see how that could work. First, since I have the string 0, 0 is in my language, I need to have a rule for sure that can generate that string itself. So I'm going to add that to my start, add that rule using my start variable. So my start variable can create the terminal 0. Likewise, once I have some string, I can add zeros to either side. I can add ones to either side. I can add a 0 and a 1 in that order. Or I can add a 1 and a 0. Okay? And now how does it terminate? It terminates by taking this first rule. So what I'm basically building is I'm building the outsides, and then when I'm ready to be done, I replace the middle symbol with a 0. And that's how I guarantee my middle symbol is a 0. And also, if you notice, every rule, except for the first one, is going to generate 2 symbols. Okay? So if I take rules, if I'm doing a derivation and I'm applying rules 2, 3, 4, or 5, I'm going to continuously get an even number of symbols. Now when I'm ready to stop, okay, before I've terminated, I'm on my last step, I have an even number of symbols, and then I apply rule 1. That's going to give me one more terminal. I had an even number of terminals plus 1 is automatically an odd. So that's how I'm going to guarantee my odd length. Okay, so this grammar is guaranteeing the 2 conditions. One is odd length. So when we have odd length, okay, and this is because rules 2 through 5 create even number of terminals. Let's call that even number 2k. Rule 1 creates 1 terminal. So then my length of W is always going to be 2k plus 1. okay? And k could be 0, and then we end up with just a string 0. Okay, and the second thing that it does, I said, is it guarantees 0 to be the middle symbol. Okay, why is this? I'm going to use my number again, k. So it's going to generate some string, let's call it w1, 0, w2. So here, length of w1 equals k, length of w2 equals k. So then I basically have k symbols, the middle one is always 0. Okay, and this is because we're creating them in pairs. So, let's confirm that this, so we've given a logical argument as to why this works. Let's use a practical argument. Let's pick a string and see how to generate it. So let's use this one. Let's use 1010100. So let me write this at the top here so I don't forget. What do I have? 100? Yeah. 2, 3, 4, 5, 6, 7. Yeah. Okay. So how are we going to create this one? Let's work. Our grammar works from the outside in. So S needs to use the rule 1S0. Let's clarify 1S0. That's rule 5. Okay, now I'm going to kind of cross these things off as we create them. So I've got that one and that one. Okay, now I'm going to apply the rule 0S0. Okay, so I've got 1, S gets replaced with 0S0, and then my 0 I had before. So now I've got these two guys. Okay, now I need to use the rule 1S1. So I've got 1, 0, S gets replaced with 1, S1, and then I've got my 0, 0, so now I've got these two guys. Okay, and then my final rule I'm going to use is rule 1, where I replace S with 0. So I get 1, 0, 1, 0, 1, 0, 0. It's my final 0. I have 3 here, 3 here, 1 here in the middle. So I've satisfied the condition, the length is 7, and the middle symbol is a 0. Okay. I don't think we need to do any other examples. I think it's pretty clear at this point.